Good morning, Olivia. Good morning, Olivia. Or
Good.
good afternoon.
Here, I was listening to the sound. Yes. Good afternoon, good evening, Jose. Here we
How's
are
it?
on another stream. The
The
last one.
last, the last of the season.
The last of the season.
Yes.
We are
Wow.
coming back August. What is it? What's the exact day again? August 18th?
The 18th, yes. Just the
18th,
18th.
yes.
With a little change in schedule. Like
We'll change
a
in
little
time.
bit.
It'll be 2 hours
Yeah.
earlier.
Yes, a little bit earlier. So to give these guys Central Europe to get a chance to actually watch
Yes.
it.
We're not keeping Jose awake.
It's quite exactly like last time. Like 2 weeks ago, we still have lots of light.
That's
I hope
true.
there will be hello, and there is no storm coming.
If there's a thunderstorm, I will laugh because it was really adding something to the alien
Yeah,
hunt, like in the storm. It's sort of like the opening scenes of Thor. With the storm, they're driving around, they're finding
yeah.
the storm, the vortex, or whatever it is. Yeah,
Especially with aliens and such. Yeah.
yeah, the aliens. It was very unique. We're gonna wait for more people to come on the stream. Also, everybody, we have a promo code at the bottom of the stream. So if you want to have more API credits, just go ahead and use that. We've put a link up before, but we're trying
Yeah.
just the promo code, so you can
How,
experiment even more.
we didn't test today, so I don't know how if my microphone is high, is the volume is high enough.
I think it is okay. Hopefully good.
Okay. If
Let's see.
someone can on the
Let
stream
us
can
know
check,
if you
let
can't
us
hear
know
us.
if you can hear us. Yeah.
Hey, thanks, Frank.
Yeah.
Cool, cool,
You,
cool. So
I was very disappointed last time we couldn't finish that topic. That's why I want to finish a little part of the geofencing part of the our alien tracking.
yes,
Yeah.
we want to get some simple friends reports because we never found out whether the aliens could actually escape. It's a really key part of the plot that we didn't get to because we had so much to do.
Yes. Today is also exciting. This topic about matrix routing and in combination with fleet management and logistics. It's very interesting, especially when we're trying to solve one of the most common problems for delivery companies, for
Yeah,
example.
yeah. Talking a lot about how you can really optimize destinations, but also what that means in a math sense because I'm a math nerd. So I will talk about it in that sort of way because I don't know. That's why I'm here, is to really make it a nerdy math conversation for anybody out there who's into it. But it has a lot of very good fleet applications, right? Lots of
Yeah.
different ways to optimize it. So I'm thinking, I don't know how many people we have on the stream. Part of me thinks we should get started.
Sure.
Or maybe, I think we should get started. We have people coming on the stream. Hello, hello.
Hello.
If you're joining the stream, welcome. All right.
So,
Should
so
we get going?
how do we start with? Should we start with the last demo we have for the checking the aliens?
Well, yeah, I'll go through the couple slides that we have real quick,
Okay.
just on what we're going to be doing. So we're going to actually do the simple fence reports. I know I put that in the last one, but today we're actually going to go ahead and wrap up the geofencing, and be able to show you whether an object is in or out of the fence that we set in Roswell. Because remember, we geofenced Roswell so that we could just play into the whole alien conspiracy theories because we like that here on the stream. So we'll go through that demo really quickly, and you can always go back and watch the previous stream for more on how to set up the geofencing. It was very complex and took really a long time, but hopefully we covered it to a really detailed level to where you can try it out yourself. But then we'll go into the main topic for us, which is really the matrix routing and how we shift the type of routing that we do to really optimize different stops. So doing distance calculation algorithms, saying we have distances, which is how the math works, but what are distances as routes, right? Optimizing routes based on time and distance, which are not necessarily the same thing when you have traffic. We'll talk about the traveling salesman problem, which if you're a math person, you'll kind of know this is the origin of sort of the cost calculation for different distances, and that's sort of the base level of everything, right? First off, I'm going to lay the groundwork for the traveling salesman problem. Or we can come back to traveling salesman problem and talk about geofencing first. What do you think, Jose?
I think better close the geofencing.
Let's close that up real quick, as we have traveling
quickly.
salesman, so you'll get the sneak peek. But I'll come back to this. We'll talk about geofencing first. So let's do it. Here we go.
Let me see. I can share my screen. Let me see if it's visible.
There you go. Yeah, your screen is up now.
Excellent. So last week we were creating a project for tracking an object using the location history API and using the geofencing API. So we created a fence around Roswell, and this is the first time that we got the fence here visible. and yeah,
and there's a small alien.
I think we just click on it, and yes, I remember. So every time we just click on it, we send the location.
So every time that's sending back the location, yeah.
Right, and then we stored them for later. That's what we did last time. And then we didn't. What we forgot to do, we didn't have much time to do last time, is to get a report of the alien's position. So I'm going to skip over the code a little bit and just go show you how it's supposed to do. When you click check geofences, what I do is make a call on the geofencing API, getting the specific report with this object. And you can see in the bottom of the screen, it says here that the object is outside Roswell for how many meters? There are in meters. And if you move inside, you get the report.
This is the fun part.
Yeah, this is the fun part. And it says it's inside Roswell and outside Sacramento.
And we had a great conversation this morning because Jose pings me and says, "Did you set up a geofence in Sacramento?" And I said,
"Do we have
no,
a
I did not."
in Sacramento?
And it turns out
I thought you did it.
You thought I did it. I thought I did it
okay.
even. That's
okay,
something
hold on
I
a
would do.
second. I'll go.
So it turns out that we did that in the last stream.
It looks like we have a geofencing in Sacramento. Let me see. I'll go back to the Postman collection, the fences. Yes, actually we do.
You see the fence in Sacramento that we set up during the last stream.
Yes, actually we do have Sacramento.
It's a great example of collective memory on the stream.
Yes, totally.
We forgot about the fence. And so Jose said, "There's a strange error. I'm getting this distance calculated outside of Sacramento." Do you know anything about that? So that was a great time.
So yeah, all right. So fair enough. So the geofencing API, I'm going back to the developer portal. It's go to the document. I am right now in the documentation, the geofencing API, which is I'm very happy to inform that it will be soon in the SDK. And we used the fetch API on JavaScript to actually make perform the calls, but soon we will be using our TomTom APIs to actually get them. It's going to be super easier to do that.
Much
and
easier.
You might not, yes, and you might not even need the collection on Postman.
Yeah, we have the Postman collection to make it easier, but maybe next season we'll talk about if we get to how it'll be a lot easier to set up and start out with for geofencing. But it also shows the feature right now of what's going on, because it's actually still calculating that distance all the way from Roswell to Sacramento, since we're differentiating between the two fences, which actually inadvertently is actually a very cool thing if you think about it, right? Because now we're doing the two calculations as well.
So it's as I can see, it's a get method, HTTP get. And we have to pass our project ID, which we already have, our API key, of course, and the point, the location, the lat and long location, and optional, you have to find the object. And I wanted to send the object, of course, because we're getting a report, and I want to actually be included as well in the location history API. And there is some optional parameter, which is the range. I don't use it right now for this one, which calculates how far from the other fences if you want to an extra report, to get more information, how close, inside or outside of other, close to that range, to other fences. So it's very useful, for example, when you are tracking an asset, like a delivery for a home, like a food delivery or a package delivery, and you can say, okay, the fence that we are going to collect is around the location of the delivery or the location of the distribution, and you can tell, okay, you are getting close, and tells you are around 1 kilometer, 500 meters, 200 meters, and you can set up alarms or notifications, which, by the way, it will be one of our topics for the next season. the notifications API.
Yes, we'll do an intro to the notifications API, which I think will be a really good way to, especially if, like from a fleet perspective, if you want to really wrap up that system, you can use notifications API for all sorts of things, right? Like delivery optimization, or like if there's a delay, like there are all sorts of really good use cases for that as well, right?
I like it. I like the webhooks, but I will talk about that later.
Talk about webhooks
later. Well, the webhooks, so you can also send emails, but emails it can fix, but you can also the webhooks to connect to your own backend, and you can get notification to your, like for example, to Slack or to your chat system, for example. That will be super nice.
No, that'll be fun. So we'll come up with a crafty plan for the notifications API episode, but that will be well into season 2. Which, if you're on the stream, season 2 is starting August 18th, and it'll be 2 hours earlier. We'll post lots of information. It'll be on our Twitter. It'll be everywhere. You'll see. You'll learn about it. But that's when we'll be coming back after this last episode of our first Twitch season, which has been good.
So, I wanted to give a little bit how does the result, the JSON response that comes from the geofencing report. Of course, it gives you. In this case, we're not sending a range. You just send it. Tell me what's the report of this object. Okay, it's a simple calculation of if the object is inside or outside of what fence. It's actually I would call it a trigonometrical calculation. Yeah, in this case, and features is in this case inside. There is an inside section, an outside section, and a summary. Which is what coordinates I'm sending, etc. In the inside, I wanted, interestingly enough, is to show that in the inside, in this case, we get the distance that it says it's in negative value. Negative value means it's inside. Right? This is but this distance is to the closest to the fence. The distance from your position
part of the fence.
To the closest part of the fence. Yeah. And there is a property. I think it's called here type feature prototype here geometry coordinates, right, and also there is a coordinate exactly where the fence is supposed to be calculated from. So you can also draw a line to see, okay, this is my fence and this is the position and how the distance is at to this point in the fence. I think it's very neat. We should have drawn that as well. We could have drawn it.
We could have drawn, so as in drawing also the specific points to calculate from, but we could also color code them if we wanted to.
Yeah.
Because we could color the fence segments. But that's a whole other topic, because here we are trying to get back into geofencing.
Correct. That would close what I wanted to show you quickly about the geofencing API. There is way more to discuss. We will see way more topics and features when we talk about the notification API. We will do a much complex example based with what we're going to do today, which is matrix routing and trying to solve or implementing one of the solutions of doing the traveling salesman problem. Salesman.
So that's we'll do a lot of deep dive into geofencing. If you want to see more about geofencing, also let us know so we can know what everybody wants to learn about. But that's a good segue into traveling salesman problem.
Yes.
Okay.
Now I'm going to switch back to today's topic.
Yes, I'll switch it over to my slide because I always like to not assume that anybody on the stream is necessarily super familiar with what some of these topics are, and some of these topics are sort of high level, right? Some of them you don't really get to until later, or maybe you're just not used to them. But traveling salesman problem is sort of a baseline for a lot of these distance-based calculations that we encounter in the real world, and obviously being a mapping company, it's a big center point for anything related to routing and things like that, because distances, in our case, of course, become routes. It's not just a straight diagonal distance over whatever land there is. It has to actually be formatted onto a road. But before we get to the road part, we start with the actual traveling salesman part. And so the first kind of statement is like, this is the definition of traveling salesman problem. If you look it up on the internet, what is a traveling salesman problem, you'll get some sort of edition of this answer. So like given a list of cities or distances between each pair of like locations or things like that, what is the shortest possible route that visits every single one, right? And this basically can be mapped onto, if you wanted to do the actual most basic way to represent this visually, is just drawing something like a shape that you see in the bottom right. Just drawing a set of like a square or just any type of polygon and saying, hey, this segment is this length and this segment is this length, and how do I actually visit all of them without traveling the farthest distance? How do I sort of most economically do this? And the traveling salesman problem is, of course, a really interesting mathematical concept because it's one of these, being very simple about it, is to say that it's one of the problems that we can only solve by sort of brute force checking. We don't have a universal solution to it. And you can see, we solve the traveling salesman problem, with different algorithms, and we have ways to optimize it, but they don't work for every single case, which is very, very broadly what I'm pointing to with this very interesting NP-complete graph. And if you're a math person, you can appreciate, what's going on in terms of NP-complete, which I don't need to go into specifically, but the TLDR is that it's one of these things you can only solve by checking. And that's how we calculate distances, and that's why so much energy and computing power can sometimes go into routing and all these things, is because there's no universal solution to these, which is a very interesting mathematical concept, because we think we have principles and theorems that solve things for us a lot of time, but this is not one of those cases.
It's up to companies using routing engines, for example, to decide, to calculate different possibilities, deciding what algorithm to use, how to optimize it, and to see and compare which one is the most either affordable or the cheapest or the fastest, depending on their needs, of course.
Yeah, and right, even different cities, different topographies, or different types of travel require different needs, and so you might not want to solve. There are countless algorithms for how to actually solve and optimize distances, right? If you Google them, you have a whole long list, and universities have whole long lists of theories that you have to learn on how to solve these things, and they take different priorities into account, like doing, the closest vertex here, the longest one first, or, all these different things. You can have countless types of methodologies for solving something, to really get the shortest total distance. So that means, but we'll talk about a couple today that we picked out, because probably one of the simplest solutions that is something that we can work into our own routing is the nearest neighbor algorithm. And there is a website, and there is a website that we use to actually, take some of these definitions, which is open for use, which is called tsbviz.com, so traveling salesman problem like viz.com, and which is linked, but that's where we see some of these definitions of nearest neighbor and convex hull, which is the other one we'll talk about, which is basically nearest neighbor is quite simple, saying that from a starting point, really want to sort all these remaining available points based on the distance, choose the closest point, eliminate it as a future point, and then continue doing this until there are no more points, right? So literally taking sort of your next closest point and going there at a time and removing it from then the list of possibilities of where to go next, right? So it's sort of a very simple linear way of saying, how do I get to the next closest point? So that sounds very simple, but at the same time is really quite optimal, right? If you're doing a chain of deliveries, this is pretty universally applicable. So we'll start with that one, and then the second one that I'll introduce really quickly, which is going to be a little bit more complicated, is convex hull. And this is one big math definition that basically takes a counterclockwise approach to sorting through different points and closing off like the convex shape of the routing that we do. And we'll talk about it more as we draw it out, because we'll actually draw it on the stream. But also choosing that sort of minimal cost path, right? Which talks about the gift wrapping algorithm, and this is a little bit more of a mathy definition. So if you're into math, you can say, oh, we're sorting through these different segments and choosing different points within the segment and the next closest part based on this sort of counterclockwise set of points. And then if we want to, I can actually shift over and we can talk about this convex hull by drawing it out, because drawing it out is really a better way to understand it. This is some good expository for just reading out the steps, but we can actually shift over and draw it.
Sure. Okay. Let's see if it works.
Let's see.
I have a small drawing area here. I always hesitate when there are new. We'll have to use new tools. Let's see. I found this online, free online drawing the tool. I think we could try it on. So let's see. We have in the sense that if we have a series of locations, right? I don't know if you can see the dots here. Maybe I should do it bigger. You tell me if it's visible.
Looks visible. Yeah.
Looks visible.
Yeah, it's looking good.
So, okay, let's we can go. Okay, let's assume you're going to start from here. This is the start. How about that arrow? Oh, wow, that's beautiful.
It's a beautiful arrow.
Yeah. So, what you said before in a convex algorithm, what do? We do counterclockwise, right? So we start here counterclockwise. We say, okay, which is the most closest to us left dot that would have location or final destination. I will say then it's this one, because if I draw a line here, like a vector that sweeps in angle, you will see, please, will touch this one, right? So I will do this. Okay, forgive my my inability to draw straight lines.
But that's going to the counterclockwise, like leftmost. Well, yeah.
Yes. Once you have this, you continue doing until you go back to your original location, right? So that means
that's the convex part of it.
Virtually, and then say this next one is this one. I sweep virtually. Obviously, the next one is this one. I sweep vertically. That means the next one should be this one. Yeah. Again, going back to the other side. The next one that will touch you will be this one. And then coming to this side, it will go back to the origin. So we have an initial path. Now we take the rest of the points that we didn't actually add to the path, and we take the first one on the line, could be this one or this one, doesn't matter, and we calculate which one is the closest with the shortest, not the closest, but they have the
lowest
the
cost,
shortest cost, the lowest cost.
Yeah.
Could be distance, could be price, could be weight, could be lowest cost.
Yeah,
and,
whatever the cost is.
Oh,
yeah.
This one is actually kind of in the middle.
Yeah, you picked a middle point, but we're going to say that it's that one.
Let's assume it's this one, right? So we assume it's this one. This one is in the middle. That means we have to insert this one between this, and this one and the next one. And that means I will try to do this one between this, and this one is destroyed. This line is destroyed. So that means, and the next one will be which one is the closest. In fact, it would be like, that means it should be actually the new one. It's part of the new path created. Then it will create a new connection between this one and this one. That means it will connect here, and this one is destroyed. So it will, let me see.
So then that's the complete path.
That will be at the end, because there are no more empty free nodes.
Yeah, there are no more points that we need to visit.
That would be the calculate. Oh, oops. Sorry about that.
That's okay, we took a little turn.
Yeah, a little bit. So that would be the company. As you can see, we can even optimize from there, right? Mm-hmm. Let me see. We also can do the one that we're going to implement today. I would like today, which is the nearest. What's the name?
Nearest neighbor.
Nearest neighbor.
Nearest neighbor, which is sort of a simpler rendition of convex hull almost, right?
Yeah. Correct.
Less steps, theoretically.
Yeah. Oh, I still have the red color. Let's put the yellow. Yeah. So if you have a dot here, dot here, dot here, dot here, here. Just random number and dots.
So for everybody joining the stream, we're taking a look at drawing out the nearest neighbor algorithm, right? Which is how we're going to be altering sort of our matrix routing to actually optimize distances as routes. So we're drawing that out right now.
Correct. So let's say, for example, we're going to start with this. This is our starting point. Yeah. This dot here. This is our origin. So first step is to find the closest or the point that has the lowest cost. In this case, we're doing by distance. There will be this one. So that means you put this element in the list, and then you move. This is the currently selected path, and from this location, you just repeat the operation until there are no other ones. It's actually a very simple algorithm. Yep. So from this one, you just select what is within the closest. Should be this one. From this one, you select the closest with this one. Mm-hmm. From this one, we select the closest.
So essentially building a new list of next closest points is sort of the simplest way to approach this, and also sort of the simplest way to think about it in a code kind of sense, which you'll see we go into, but that's really all it is.
Just don't miss anything. Yeah. But okay, and from here and at the end, you just go back to the final point. Now, as I mentioned before, this is nice and dandy. Yeah, but these are lines, and in real life, we don't have lines on the road, right?
Yeah, lines, you can't just,
We
you have
have
to drive on roads. You can't just drive across the free
correct.
land, you know, in your
Correct.
Humvee. It doesn't work like that.
So this is good for a mathematical example, but in real life, calculating real routes for a specific purpose, we have an issue here, because if I am starting from this point and I am calculating this route, I am not calculating a straight line. I need to calculate actually the route that goes to here, that comes to here, and it has to be calculated among which one is the closest one of all the other points, not by straight, by the route that we have to calculate.
Because the route between yourself and one of the points that you're facing may actually be longer than the actual distance, and to another point, the route might be shorter, right? So it may not be what you expect. So that's where you translate from the math part over to the actual routing part.
Let's assume that we are doing by distance, just by follow me on that. That means if we started from the next path is here, and we have to decide which one of all these dots is actually lowest in cost, and we're doing by distance, the distance could be I have to calculate the route from this from to here, and maybe the route here is actually shorter in distance than this one, because this one has to go through a road here and then come here. We don't know.
Loops, and that's what we're going to try and solve, because that's
exactly. So that means this route is not valid. This one will not ever existed. Only this route will exist. Yeah, and that's what. And in order to do these calculations, we don't want to call the routing API 3 times.
No, it would take too
7
long.
times. 10 times. Not only that,
it would cost a lot.
We calculate the route. It will cost more.
A lot of energy.
So what we want to is to have that's why we have the matrix routing. So let me see the matrix documentation. Let me see routing. Let's see methods. The matrix routing will actually give us summaries. So I don't have to create the route
because
itself.
That's what executes
Just
the
give
routing.
me the summary.
Yeah.
Exactly. Yeah. Don't give me the route. Don't pre-calculate. Give me quickly a summary from A to B, A to C, A to D, A to E, A to N, in order to get now that we have the distances, let's perform the algorithm.
And that's actually what allows us to change just from the simple A to B routing over to our own routing that we sort of implement ourselves, right? So we're taking nearest neighbor, and we're building that ourselves, right, on top of in addition to the typical routing from A to B, right? So we're making an optimization on top of it. And that's what allows us to not have to build in the actual physical routing aspect, because once we come up here, here's where we want to actually do that routing to these specific points, then that's where the summaries come in.
Yes, and when we create a matrix routing, we have to pass, of course, not only the origins and the destination, but we can also pass as parameters a lot of parameters similar to the routing API.
You can do windingness, like in thrilling routes. You can do windingness if you're trying to find, because if you're travel mode, because here we'll do truck routes. I know specifically is what we're wanting to do, because that's sort of fleet oriented. Right. But for example, if you're trying to optimize by fuel, you don't want to take winding routes. You don't want to take hilly routes. So there's all different ways to sort of layer this.
I also want to go back here, and I want to mention the following as well. That we already know that the route between A to B would be a route like this, and then when we will not do this today because it will take a little bit longer, but I have something to take into consideration when someone or is going to implement a real solution, is that when we are calculating the distance or the time of traveling between A to B, and then we assume that the truck or the assets arrive at B, and then we have to recalculate. We have to recalculate the routes based on the travel time already. So if we start here at 7 a.m. and arriving here will be at 7:15.
Yeah, because what we're doing is we're not using future dates or future times. So whenever we're updating these points that we're using, we're also, our routing is actually factoring in the traffic travel time. So all of a sudden I also have traffic as an additional layer. So distance versus traffic, as anybody knows, sometimes it doesn't come out to equal. The shortest shortest route with traffic is not really the shortest route anymore. So that has to be continually updated to really account for traffic conditions, road conditions, all these fun things that we deal with on the roads, right?
That's true. So we will not do that today, but we should actually do that in a future example, because that will give you a very accurate route calculated. Now, do you know what city is this?
City's that looks like we're in looks like we're in Singapore is what I was going to say, but
how do you know? Yes,
it's magic.
Magic. We are in Singapore. In this small map. Okay, I think my map is square. I can see. I don't like the square. I'm going to change this to be a little bit longer.
Did we? No, we didn't route to Singapore during the James Bond episode, did we?
No, we didn't.
Did Hong Kong to Macau.
We did Hong Kong to Macau.
But we thought about Singapore because Singapore was also a film location, I think, for one of them.
Was it?
I think it was. I think there was some filming for one of them in Singapore, or it was like a set, like a alleged location, right? Like a plot location. Because I don't know. So the fun facts. We might have routed to Singapore before, but we didn't. So here we are.
Now we are in
Singapore.
We're in Singapore. We have a nice map here. So what I have created today, okay, just because we've been doing this already for several episodes, it's just create a normal route, right? So let's see if I start a route from here. This is a little truck, a little van, a delivery van, and they have to deliver to different locations. Let's see, I can put it in one place in Tampines. It's a residential neighborhood, and we can go here, another one, and here, for example. So if I do a normal route, it will be okay. We are receiving the orders, and you have to go to number 1, then number 2, number 3. Number route, let's see. Effectively, it will be okay. You have to another route from 1, then to 2, then go to 3, and then come back.
And this is done in a manual order, basically, is what's going on. So this is basically saying, oh, hey, in the points, in the order that are sent, and we route to them. Right, so whatever, even though if that order is not, it doesn't optimize the order of the points. It's just saying, okay, this is point 2, this is point 3, we go to each of them.
True. And in the code, I added one single button to say normal route. Maybe we should now add we're gonna add another button. Let's see. How's the code? Can you see the code?
Yep.
Yeah. We're gonna click. We're gonna call it optimize route.
Mm-hmm.
Optimize route. So
this is what will make our nearest neighbor route calculation.
Correct. We're gonna make a small calculation. We're gonna follow the code a little bit. So, of course, I have created in advance how to create the marker. So that's why.
So things from the previous episodes, like simple routing and creating the marker, you can go back and watch them. But we skip over them here, just so that we can get to our points.
Done.
Yeah.
Let's see. Okay, so now we have optimized route, which actually failed, of course, because we haven't created the.
This makes sense.
We haven't created the. Oh no, we haven't created the button. We're telling it to have to execute this from a function that we haven't created.
We have no function. We just have a button.
Yeah, it's not function. We just an empty thing. So, remember how do I like to create functions? How to create? Optimize route is called function, and this is our function, for example. And what we want to do is to actually execute somehow the layer. We're going to create the whole process. Yeah, they create the nearest neighbor somehow, and let's see. We already have all the code, all the points for the route. We have it in this variable called points. I think I have created here. Yeah, points. Yep. It's an array of points, and I added a little twist on the object. It's not the points. Is an array of elements or JSON elements, and every element contains a name and contains the location, the lat and long location. So I do that in order in order to have a better visibility of the markers, so I can know what markers is the 1, the 2, the 3, right? In order to display it and also to actually index it later. And that's exactly that's the only change I did from the previous examples I had. And what we want to do is, okay, we have an array of points already, and we have to find, okay, the first thing I think we have to get is, I like to make a copy. I'm going to make a copy of the current set of points. Mm-hmm. You have to make a copy of certain points. Let's see, it's dots, 3 dots or 2 dots? Wait, I think it's 3 dots. I don't remember completely. Yeah. So what it does is I'm going to make a copy of this array, because we're going to modify the array. So we have all the points in this array. We're going to extract them one by one, calculate the root of each one, and then we're going to extract the lowest cost, put it on the new path, and then only modify the array. So I don't want to modify the array for if we need it later, so I want to make a copy.
And that's what we were talking about with the nearest neighbors, right? We're saying you're building your route basing off each next lowest cost point. So we're going to basically pop off the lowest cost vertex that we see and calculate it from the previous, then find the next lowest cost and add it to that array. So that's basically what we're going to be doing in a very brief sense.
Yeah, we're going to create a new path as well. Okay, this path is the path that we're going to send to the new root layer in order to create the new root, to add the new root. So the path should contain, the path should contain the points that will be recalculated. Well, I think the first point that you have to get is the origin. I'm forgetting that. So for endpoints, which is the array, just give me the origin one, which is the first one. So if you know shift, we'll take for the array, we'll take the first element of the array, take it out, return it, and I will create a path with this, and then my new array is shrink by 1, which is the same array without the first one. Okay, so now we go on a loop for the rest of the points until there are no elements in that array. So let me see. Okay, let's go while. Okay.
So that's how we're basically building the neighbor array.
The algorithm, yes. While there is elements, right? While there are elements in this. This is terrible. I like to.
Okay. You roasted your own
While
code.
there are elements in the array. Very critical. Yeah, I do that. While the array is full, what we want to do is to calculate the distance of each one, right? So the best way to do that is to call the matrix routing first, and then get all the summaries and values, and we have to sort. We sort the endpoints array, for example. You see, I think the easiest way. Okay, let me just follow my train of thought. I try to find out how to do this. Okay, let me say sort.
Because then, we'll have. Which is, I don't know if we want to pull this in yet, but of course we have the whole async, await, and so we want to not go over the calls per second that we want to have, right? So we'll have to make a waiting time for calling matrix.
Yeah. Oh, that's not how it is done. It's actually like this. So we have a function. Sort will actually receive a function which is setting the 2 elements, and the function will return a value telling in what order is the element between the relationship between the other. So that means I need to get the cost. I'm going to return the difference. So if the cost of the one return the cost of the other, or the other one is greater, they will be in certain locations. If it's minus, it will be inverted, or left. Or if it's 0, it have the same value. So I'm gonna get the cost from the current one. Let's call it last point. is the last point of the current path that we're creating, the last point, with the second one, and the difference within these two. Last point, A. So this will sort the points array depending on the difference of the cost. Yeah. So I want to know if this cost is higher, go first. If the cost is lower, go later. Because at the end of this, at the end of the sort, what I want is to take from the path, update the path with the one after the sort is done, the last one, which is the lowest cost.
And that's how we continually build that path. So we're kind of like recursively building.
Yeah. How do you get the last one?
The pop?
Pop.
Yeah.
Yeah. Thank you. Yeah. So we pop the last one, re-update the current array of working, and put the past one inside the current path. And at the end, I think we have to do a little thing at the end. Should be path. Since the path one at the end, we have to go back to the first one.
Yes. Yeah. Because we have to. Well, in this case, we're making it sort of a complete row. You go back to the beginning, right?
Yeah. Yeah, to the first one. Just push the path, the first element again. Yeah. And now this path will actually already give a list of the order. And okay, then we have the path, and then we just have to draw it.
Yep, and I know we were thinking about drawing by distance and also by time, but we'll start off drawing one, and then if we draw a second one, it'll be you can see the difference. Sometimes it's not different, but we'll start off drawing that path so you can see the differences. But you can already see the difference necessarily between the normal route, right, and between the optimized route with the nearest neighbor.
Yeah. So in order to get wait. First, let me just clean up a little bit here. Yeah, I have to clean up here a little bit. Where are we?
We're still looking at the loop where we're building the nearest neighbor array, basically.
Yeah, I'm kind of lost right now. Oh yeah. My mouse was on the other side, on the other screen. Oh,
it's the aliens. You have to blame the aliens. They didn't like that we geofenced Sacramento, and that's what happens.
Yeah. For example, I have here the variable last point. So inside the the last point, I have to always to get the last point. So it has to be inside the while is last point.
Yep.
Let's put up last point. The last point is equal also it's always the last element of the path, right? So what's the last element of the path? Length.
I think it's good to probably note right now that what's happening is that whenever this cost changes, so basically there are sort of vertex-based sort of cost recalculations, right, that are happening. We call the matrix routing to really optimize what's going on as well with traffic, right, as we go from point to point, because it can change pretty rapidly.
Yeah. Okay, and now we have the last point, and to get the cost of each one, to get the cost from this is actually from last point to the B, last point to C, last point to all of these elements. We don't want to call the routing API all the time. We have to get the values from somewhere. So what I suggest is to execute first the matrix routing in advance, and get all these values first on in an array, for example. Yeah, and unfortunately, I do have I have this somewhere because I get these values again, and I want to make let me see. I already have that coded like some weeks ago, because I have to doing a demo for matrix routing, and I got from one point. I got from one point. I already got the location, and I returned. Also, I want you to make notice of something. If you go to the documentation in the SDK for web, matrix routing, the parameters of part of the constructor. What we got after passing all the parameters, look, we get, when you say go, we get a promise. That implies that it will be executed asynchronously.
Yeah, which is going to affect our calls per second. Yeah.
Yeah, I already had that issue before, so I have to add a function that gets all the summaries and using await and using creating an asynchronous call. So I think okay. Let me just find it here. I think I have it already in the tools section, and I'm going to go to the tools. I think, do I have the tool sections here? Yes, the tool section is a JavaScript file, and yeah, I remember. Yeah, I have a get summaries. So I have a get summaries from the points, from the last point to an array. And what we have to do is I'm going to create. Note that it's an async function. I'm going to create all the parameters. First is the origin. The origin is only one, which is when we calculate from the current one to the rest. Destinations are all the elements that are in the points, lat and long locations. We create the objects on it in an array, and then we execute. We call service matrix routing.
Yep.
And this one I will call with await because I needed to finish first before I should continue. Otherwise, it will launch there, and we have many issues.
Yep.
So, but I needed to stop there, and I want to make sure that okay, we have the origins here, we have the destinations here. The travel mode is truck. We add in place traffic through. I think, but it's on by default, and then say go. When I go, this will make the call, execute, and whenever I get the response, it will be in this object here, the root GeoJSON. And then we have a matrix that I want to create, an array, and every element of this array is actually an object that has the distance and the time to record that segment. Have this, I push the element in a name, distance, and time, and I want you to maybe we should actually see it somehow. Okay.
But this is where we see like the wait 1 second. So we're basically making sure that we have like 1 second per call, so that we don't get everything crossed.
Oh yeah. Yes. I have here. I have to wait 1 second as well. I wanted to wait 1 second because it could be making more than 5 calls, for example, per second, and I would want to go over.
That's a very important part. So yeah, the per second sort of budget. So we want to make sure to have like the wait 1 second is the important part of this segment too.
Yeah. So right now this method is called get summaries, and then I want to get the summaries. I want to get this. I want to get the summaries before I have to actually make the comparisons. Let's see. Let's see. Where do I put it? Where do we put it? Before the sort. Yeah. So let's go the matrix. The collect matrix or as a matrix result, and we say please execute this, which is called get summaries.
Get summaries being the key where we're actually doing all the routing. If you're joining the stream, right? This is where we're executing all the actual matrix routing.
The matrix routing, and we want to from this want to pass the last location, which is the last point. The summary is against the last point against the rest of the current path that we're working. So that means endpoints. Once we get the summaries, then we can get the cost because the matrix is saved. Oh, can we see it?
Can we see? Because this is also how we'll see the different, sort of like segment costs. So it's sort of aligning to, right, these topics of, distances and distance costs, right? And so we're thinking of routes as spanning trees, but also not.
Yeah.
Because they're on roads.
Yeah. see it.
Let's see it.
And at the end, and then at the end we say in the console, let's see.
Let's see the matrix, right?
Let's see the path.
Or yeah.
Let's see the path. Yeah, the final solution. Yeah, and that happens when we increase optimize route.
Yep.
Let's see.
Let's see what happens.
And let's read. So I'll reload. Okay, wait. Oh, okay. You see, we have an error here in the index 120. Yes, it's because no. It's the I'm using await is only for the valid in a valid async function, which is in line 120. Yeah, this awaiting summaries in my two. Oh, but it's an async function. I don't understand. Let's see.
Are making some calls out of order?
Maybe so. Yeah. Awaits only a valid async function. Oh, wait. Something is wrong.
That's what happens when aliens take the map.
You keep pushing the alien agenda.
I liked the alien theme. Way too much, apparently.
Yeah. Okay, let me say. Okay, let me just go here. I know what's happening. I know what's happening. The function, because we're calling await here, have to go also asynchronous here. That's why. We cannot call await here unless you are in an asynchronous function. Let's see. All right. Very tricky. Yeah, the map is back. So let's see if we are here, and we have to go destination number 1, destination number 3, destination number 4. Okay, optimize the route. And another one. Yes, of course. We haven't calculated the cost.
No, we need to calculate the
cost. We have the summary. We did have a summary. Look at this method here. We did have a summary, and
you can see
the matrix is clearly defined. Yeah, we have to he started saying from 0, from the element 0, which is the origin, to element 1, which is this one. It will take so much time, and from a distance so many meters, and from 0 to element 2, 0 to element 3.
So we're building the matrix out, but we haven't.
Yeah, and at the end we need to get the cost. Otherwise you cannot get the path. Yeah. So the cost is simple. It's just we have the matrix. We have the array, which is called matrix, and we just fetch the value that we're looking for. Let me see. Let me see if I can find it here. I think I already have this before. Here. So, what was the cost? Var. What's it called? Get cost. Get cost. Cool. Get cost. And the cost receive what? First, get cost is a function that has a get cost has here current point and the other point. So they have 2 points. Get cost has 2 points. So we calculate point 1 and point 2, for example, right? And what we want is go over the elements in the matrix that we're passing through. Oh, okay. Matrix is here. No, we can pass it, or we can make it global. We can pass it to get cost. Get cost as well. Pass a parameter. So I just want to make it work. And let's see. As you remember, every point has a name, and the name has the point A to point B is created in a formula. But okay, what I want to do is to element that goes in this array, matrix array, And if the element name is equal to the name that we're looking for, name element name before, which is a name is from A to B. This is the A to B location. This actually we have a name for every all element called it's like a combinations of the two. I think it was a on this slide we post the point one, give me the name, and then we added an arrow. I will check in a moment this, because I remember I did that at the beginning from the normal route. Point two, give me the name, and at the end close the so if this is the name, then please return let's say, are we calculating by distance or by time?
Let's calculate, I know we want to do by time, by either one, but let's do just by time maybe.
Yep, and that means the time to takes to travel this specific route. Just return the time. And let's see, it goes over. Now let me just double check the cost, the name that we are calculating here. When we were creating before the click the elements, the points of destinations, we add them. Where would we add them? I don't see it. Let me see. Okay. What's the name? Oh, we've been see the tools. Get the summaries. Oh yeah, the name that we are creating when we create the summary is open bracket, give me the name, a little arrow, give me the other name, close the bracket. So that's why I remember this part.
So now that we have the points named.
Well, yeah, justify it because this is the name on the array. Now I want to get the time, right? And the time is the cost, and then we got finally a value. Let me see. We have to reload. So let's start from here. Boom, boom, boom. Optimize the route. And okay, time is not defined. Oh, good point. It didn't get cost. Let me think, because probably we are not getting the
we may have set it up for
value.
Distance or.
No, it's not that. Probably it's the element that is not we're passing a wrong value. That can happen. That can happen. Yeah, obviously, time doesn't exist. It's just we have to set the element. That time. That's what happened. So let's do it again. So we started from here, go, for example, and we have the path, and every second we got all the calls. So I don't really know exactly which one is this one. Okay, these are a result of the summary. This is and this is the last one, which is the last
So we're
path.
getting each of the sort of iterations of the path getting put out.
Yeah, correct. And as you can see in the last one, it is the path. It says, okay, first one is go to 0. Then go to 2, which is this one, then go to 3, then go to element 1, and then go back to space. So we can do one with a more complicated one. Let's see how it goes. How many elements do you think we can actually manage to get? Go. So every time we go in the loop, 9 elements. That means we have to go 9 every second.
It'll take a little while.
9 seconds.
Yeah.
So we can see them more visible for people to see. Yeah, at the end we have 11 elements, and then see this is the path that we should go. 0, 7, 1, 6, 9.
So let's see. I know we're coming up on time, but we have the path set right on.
Yeah.
Basically, we have the output of Sort of each time we're making this loop of, what is the decision to the next vertex that we'd be traveling to, which is basically us defining the nearest neighbor along roads, but incorporating the route information and the traffic information where we would like to be going.
Yeah. So now we just simply want to draw the route.
Yeah, now we just draw the actual path.
The actual path. So for that, let me see. How do we do this? Well, we have we create a route. That's all. We have the path already. Now we know how it's supposed to be going. This is the first time we're going to create a path for this. So, okay, let me see if I can create a route with this value. But actually, we can. Oh, sorry, I'm on the wrong screen. Okay, we created the route here. We call create route, and we pass the options that we want. For example, we have a color and in what element we want to create the route. So we can just copy this part here and route, for example. So this is the code to withdraw a normal route. That's how we draw a normal route. And when we get the path at the end, we can. This is not en route, it's actually the path that we want to draw. We have to select its travel mode road, and we can set color blue.
That shows us the normal route.
And the ID is the. I think we have an ID in the div in order to put the element. Like there are some kind of report, we can create a new ID called optimized route, and then at the last element we call it optimized route. So this one I think will draw the route that we just created in a new path. Let's see how it looks like. Let's reload this, and let's see. We start here. Go element number 1, 2, 3. Let's say 4. That's the optimized route. 4 element, 3, 2, 1. Boom. Oh, very nice.
Yeah, now we see.
So as you can see, the optimized route says is 58 kilometers, and it will take so many seconds, so 5,000 seconds. Of course, we have to convert it into.
Yeah, but that's total seconds. Yeah.
Yeah. If I do a normal route in comparison, it will do the green one, but now the normal route is actually 86 kilometers in length.
So we have roughly like 2/3 of the original route, or something like that.
We have optimized a route properly. Again, we have to also note, make sure that even that we are telling us the final user that you have the final. The final solution is from origin to point destination number 2. When we assume that we arrive at destination number 2, we have to, the next iteration, which is the next one in the algorithm, we have to recalculate based on the distance that we already at the time that we already covered, because at that time could be 20 minutes later. The traffic information, traffic incidents, traffic flow could be
we have to update, because we do factor in the traffic.
Yeah. It's very important to create a really accurate picture of how the route could be optimized.
And that's
nice.
That's the difference between using nearest neighbor and using the traditional normal route that you would otherwise use.
Correct. Want to do another example before we close?
Let's see. I know we're coming up on
Singapore. 03. Yes. So
let's see.
Just quickly let's go to here and let's go downtown. Usually it's coming downtown. Let's go for a different route, the optimized route. It's blue.
See the matrix.
Yes, see the matrix. Let's go the normal route. The normal route says it's 23 kilometers, and the optimized is 18 kilometers. So it's
so it's still a good bit shorter, and you're still saving a good amount of time. Because it's also taking you different ways. because it's not completely overlaying the other original route. Like we see a few detours that we make to actually save time because say there's some sort of traffic buildup or one is like longer, slower, something, right, is causing us to go a different way.
That is true. What I would like to do in the next possibility, and the next devisode, is to simulate the little van moving towards your destination, and whenever you close, we create a fence on it and create a notification. That
sort of real-time travel, and then we have a notification.
Real-time travel.
But that would be an actual full fleet sort of suite simulation, right? Because then we have the notification of when you enter the area, we have the optimized delivery route, and that's the whole sort of fleet picture in a very small example.
So don't forget, everything about the matrix routing in the documentation is obviously in our developer portal, routing API.
And we'll always put up videos. We usually make a clip of some of the most key parts of the stream. You can always rewatch the stream later. You can always watch the clips we make. You can also make your own clips and post them if you found part of it specifically helpful for other people too.
Yes.
And let us know what you think.
Yeah. All these videos and episodes will be, of course, in our. I forgot to mention our YouTube channel.
YouTube channel.
We're going to have. Yes, we're going to have a YouTube channel soon.
So that
I'm very excited about that. So we're gonna all these episodes they are already planned to be in the YouTube
everything that we've
for...
streamed will be on the on our YouTube channel. So you can, if you don't want to watch it on Twitch, you can watch it there. Anything like that, you can save it into your account. All these sorts of things.
Yes. I think that's it for today.
That's it for today. So thanks for joining our matrix routing adventure, and this is our last season 1 devisode. So it's been fun doing our season 1, and then after a little bit of break, we'll come up for season 2, and we'll start out with the map styler, which will be a lot of fun.
Don't forget to use our coupon code.
Yeah, use it for more API credits. So when you start building, you have even more API transactions that you can use with DevFleet too.
Exactly.
All right. Have a good one. Happy mapping, everybody.
Yeah. Thank